So here we have one with parametric equations that we're going to eliminate, and they are trigonometric parametric equations. Okay, so we're saying x equals 4 cosine t. Oops, that's going to look wrong. Cosine t. This one's going to be kind of interesting. So you get x over 4 equals cosine t. And then you're on the other one, you're going to have y equals 3 sine t, or y over 3 equals sine t. And then what we're going to use is we're going to use an identity. So we know that cosine squared t plus sine squared t is equal to 1. Now, I did write the cosine squared first, but you'll see why in a minute. So when we plug in what we have for cosine and sine, it's going to look like this. X over 4 squared plus y over 3 squared equals 1. Now, I'm going to write it like this. X squared over 16 plus y squared over 9 equals 1. That is the standard form for an ellipse, okay? So you might remember, so a little review on an ellipse, centered at the origin. That's x squared over a squared plus y squared over b squared equals 1. So hopefully in your past some math class, you talked about conic sections. And this is an example of one. Okay, so I'm just kind of reviewing it, showing it here for you. So the A in this case is 4 and the B is 3. And what I usually do to graph these, I just go out 4 units on the x-axis in both directions. 1, 2, 3, 4. And then I go up and down 3 in this case because B is 3. I feel like that one dot's off. It is. Okay, let's put it in the right spot. Oops. Okay, and then this is going to be an ellipse, and I just try to draw it the best I can. Try not to make it look like a football, but anyway, they didn't ask us to graph it. Oh yeah, they did. It says sketch the graph. Okay, so here's the Cartesian equation. It is in the form of an ellipse centered about the origin. And that's the way I graph them. You could find more ordered pairs. It just would be more labor intensive. And just try to draw an ellipse. So